Thank you for inviting me. And just to say some words about myself, I'm Gianluca Vitale. I'm in charge in AVL for virtual tasting and smart calibration. Just briefly about who I am, I come from the dark side of development. What I mean by this is that basically I previously worked for engine calibration programs, so I'm coming from the side of the V model, which is heavily dealing with real testing, which is basically not what we would like to discuss today. The question here also, as all the previous colleague was talking about simulations, would you trust them with your life? I think this is a nice question that I would like to somehow contradict with three main points. I think that this question has a strong assumptions behind, which I believe that need some more detailed explanation, because the reality is not black and white. The reality is it's more complex, and it's not a question whether simulation makes sense or not, but the key point is to which combination we can bring simulation and real testing together. So for me, the first assumption behind this question is that the testing is in our mind what we use for validating and certificating. Well, the question is if testing is only used for validation and certification, and the answer is no, it's not correct. Testing is massively used also for making development decisions. So for example, if you look at this table is an overview of a development program where you need, for a variety of tasks, you need different testing environments. So you see that this is a traditional way of working that is strongly relying on road testing. And you know that in the road testing, you need a lot of vehicle prototypes, which are quite expensive. The question is, why do we use so much testing? I'm saying, well, that's not just for validation and certification. We are using this also for making development decisions. So it means there is a high potential of tasks that we can front load in other testing environment with the support of simulation. Just to give you an example, we have done internally a lot of such programs and development programs. And this is the picture as it looks like when we apply simulation in the development. Well, you see that you cannot make an average, but just to give you a feeling, we are talking about 30–40% of testing effort that can be substituted easily by simulation. I'm not talking here about validation and certification. I'm talking really about decisions concerning development. So this is the first thing. So simulation is not only used to validate, to certificate, but is of course easily used to make design decisions. And that is what I think it's really a pity that we are not using so much, because it's something that it doesn't require the certainty that the simulation results is accurate. It's something that is providing us an orientation. The question is, why do we don't do this? Well, we didn't do this in the past because simulation was basically done for simulation experts. The guys that are dealing with testing and designing a new car, they are not used to these kinds of tools. They don't have these skills. So the key is now providing simulation technologies for development engineers rather than for simulation experts. And then we see that with this, basically the utilization is increased. Second assumption behind your question is that simulation will substitute real testing. Well, this is again not true. It's not whether we use simulation or real testing. Again, I repeat, it's a mixture. Just to make you an example, if for China 6, for a truck engine, you're going to make kinds of climatic testing, you know that you need to certificate the truck also at different altitudes and environmental conditions. Well, what we are looking to do during your development is trying to ensure that the design and development decision you do with your engine will fulfill in real life these kinds of legislation restrictions. Well, what you typically do is that you rent a climatic testbed, and climatic testbed is quite an expensive laboratory. And you take your engine, you go over there, and you start doing your testing. And the majority of the testing you do is used for development decisions, which is this green part. And only when you're done with your decisions, whether to optimize, to change a strategy or to use another software or to maybe change something about the intercooler, then you start making your validation tests, which will give you let's say the trust that the engine will fulfill the legislation. In the reality is that when you are really doing this job and you are in a climatic test, you know that there are a lot of inefficiency due to bad preparation. So, for example, you suddenly you develop that you discover that basically there is a bug, or there is a wrong software version, or your test was done in a wrong way. So you need to reconfigure everything. But then when you are there, of course, you will see that you will lose very precious time. That's why by using a model-based approach, what we typically do in our development programs is that before going to such expensive climatic testing, we have everything virtually available. And when I say everything, it's not just the powertrain and the vehicle, but I mean also the all control software that is used to control the system. What we do is basically we repeat the whole testing in a virtual environment. And it happens that we prepare our software so good that when we go on the climatic test bed, finally the utilization is very, very efficient. We had projects where we could push the efficiency up to a reduction of 80% for this climatic testing. So also here is important to say that simulation is not substituting testing. It's rather that simulation is a very, very good and robust preparation, and avoiding that we have also huge development costs in the testing. Last assumption that we usually do is that validation and certification is about synthetic testing. What do I mean by this? Well, we are using a word where basically once you develop your system, you need to validate and certify in a laboratory, okay? So, and when you do this test in the laboratory, what you try to do is to represent the reality. So how does the traditional development process look like? So you have, you simulate something, you make some decisions, and then you go into the testing laboratory, and then you go into these kinds of environmental test strips. So you build a prototype car, you have some dozens of these cars, they are very expensive, and then you need to find the right climatic condition to test them. So you need to really take these cars and physically move to Sweden, to Spain, to New Zealand, whatever around the world when you have where you have this issue. So, and then the product is delivered to the market. But we know that this is just about representing the reality, it's not the reality. We know that this also, we have limited and costly real life testing possibility. It's also difficult to correlate the test road to testbed because you have different conditions, you have different stages in the development, and we also know how difficult it is when something went wrong, and we discovered this later in the process with all these recall sections of software and so on. Now, what we have learned from what we know very good is that basically when you try to give a robust decision about your design concept, which is the blue dot here into this surface. So you try to put this blue dot, which is your decision, inside the green area. But you know that statistics, in the reality, you have a lot of disturbances. So it may happen that your decision will shift to one of these red dots, and then you have the issue in the field. So the robustness of the decision, it is based purely on synthetic testing, which of course try to represent the reality, but it is not the reality. That is why at AVL we talk about augmented development. What do we mean by this? Well, still the solid rock behind the validation is the testing laboratory, with also these kinds of environmental test strips with prototype cars. But we augment this dimension by further two dimensions. The first is what we call digital reality, and is the capability that every company needs to build to represent the reality with every detail. We have seen in the keynotes a representation of cities. This is, of course, a topic, but it means also a high fidelity representation of the cars a high fidelity representation of the roads, a high fidelity representation of the technology which is also inside the car. The other dimension is what we call in-use reality. In-use reality is the real profile that and utilization and data that we use. And these two dimensions are a very powerful way to extend the current development process. So as a matter of fact, you see, you don't have anymore a design decision, which is this distribution in the upper part, but you go down with your decision in an area where your decision is more robust. And this is all what we know also since the past, but the difference that today, the big chance that we have today is that we can use big data coming from the in-use, and with this big data, making really based on simulation, highly robust decisions on the design process, which ensure that basically the failure rate into the reality, it's much lower. Simulation is basically a chance combined with big data to actually make better decisions for our products. That's it. Thank you.
Thank you, Gianluca.